Transformation.
It's like, how far around is it?
Alright, we're going to start this off with some notes that we've taken in the past, but they're going to relate more to polynomial functions. So I'm going to make us a little table that we're going to copy. So let me get it copied, then I'll move out of your way and you can copy it. Yeah.
This is a big one. It's a table.
It's for the D, I just don't know what it is.
Oh.
The first time I read it.
The first episode?
How about
It's so good.
No, you like,
Oh, I watched first, second, and third before you put it on tomorrow.
Wait. Hey, bro.
so apparently if it rains at 6, you have to keep running. I can't even get hours. And then, like, if it lightens,
I don't think anyone
but
should use
that's
it.
That's how it is in softball.
Except for
If it rains, like, it's a lot.
Connor said, I can use that.
I don't know about it.
8:15.
But it should be heavy.
Yeah,
And
if
it's
it's a
supposed to be
hard
colder.
rain,
That's your birthday?
if it's a hard
Start
rain,
that.
like, that shouldn't help you. That shouldn't help you. How it is.
16.
Like, you think that it can't.
Yeah.
Wait, I'm trying to write this down,
And
dude.
then you have to run mud through it.
What if I'm...
She said wait,
you know?
Trevor. I could have told you
Why don't you
that.
listen?
Y'all know that.
I guess what time I'm getting home today? Around 4:30.
She did you a sweater.
I swear.
I tried to go to sleep at 10.
Oh,
but then
she
I
does
tried to
that. Big balance stick.
That's what I'm saying.
You like that big balance stick?
If I get mad, you know something stupid.
He's mad.
If I was
He's
the
mad.
artist, so wrong, but okay.
Thank you. Trevor.
Alright, what you're copying. The left-hand column, and this is stuff we've done before, we just haven't put it to polynomials yet. We did this with parabolas and absolute values and all that. Left-hand column there is what type of thing it is. It's a horizontal transformation or a vertical transformation, reflection, shrink or stretch, all that. Then in the middle column is what it just looks like, what the rule looks like. We use an f of x. And then on the far right is some examples. Okay, so you need to get all that. I'll scoot it up here in a minute so you can see it all.
Why, bro? Where's your notebook?
You can't use your phone on the test.
I'm gonna copy it down in my notebook.
Yeah, you can.
Trying to gang up on games. He did nothing to me. Sure should put it inside.
multi. Christian Creed, please report to multi.
We'll try.
Does this
You're not
have
candy
one
tonight?
up till something?
You are? You
What?
get candy tonight? I don't think I am either. It costs too much money. I'm broke. Yeah.
You want to like keep their practice and stuff.
Just start handing random toys. Even razors. That works.
Razors.
There's some like factory or something like that.
Hey, not to reflections yet.
What was this right here? Hang on. You should have wrote it when I did.
You do that for? You study, calculate, and put it in the bank. You are a one different. You just want to miss that one for that? Go hot.
Who makes it lunchable like that? It's calculus,
What is the last one in the middle
the
thing?
ham on top.
A times f of x.
Instead of pound.
Yeah, it's for the
What?
cracker, ham, cheese, cracker, ham.
Not like you do, just trying to register it.
Lunchables. They're just probably showing me what it has in it.
No way. I didn't know it did that.
Well, someone doesn't have very good eyes and you can see the cheese. It does look like it's supposed to be
Oh, yeah.
On the horizontal one, yeah, stretch of two. Remember on the horizontal, it's the reciprocal. Vertical is what it is, horizontal is reciprocal.
As you can see, put the speakers in one.
Gotcha.
No, sir.
Is that illegal at school? It is? Have your hand in your Yeah, no, it's not.
It's just weird.
No, it's not.
Yeah, you're supposed to do that in public.
You can do it.
I mean, it's legal too, so it's like frowned upon.
It's just weird.
Oh, man. Hold on, you ain't gotta look.
He said, my parents, I give him a little
Really, see it, German.
Oh, it's illegal for
You're
sure.
not washing your hands.
You just ate cheese with that hand.
Oh,
It's
nice.
both hands.
Hang on.
It's my stuff. Oh, why is it so hot in here?
That feels good.
No, bro.
Okay,
What
look,
is that?
Just ketchup, barbecue
What's
sauce,
that?
maybe?
Did you go?
He said,
It's like
You should
800. I'm about
cheese
to.
this,
What you drinking on?
Too much work. I don't have a shirt on.
God, I broke something.
Gee. Yeah, I would be extra food.
Connor,
I would
I'm about to give him to Connor. Here, I'll give him to Connor. Here's your cheese.
Connor did not eat those.
I didn't put my hands on all of them.
No, he didn't stick his hand in there. He.
I ain't hungry. I mean, I stuck my hand in there, but I didn't blow all
Don't
of
eat
them.
them.
They were really good. Thank you.
It's good to eat.
directions for this say, describe the transformation of f of x equals x cubed represented by g of x equals x plus 5 cubed plus 2, then graph each function. Okay, so we got to describe the transformation and we got to graph on both. Let me get a piece of graph paper ready for us.
Can you do any of this in the calculator?
It will graph them, yes.
Answer's 4.
No, it's not. Alright, so first off, describe the transformation. So from f of x to g of x, you need to notice there's two things that have been changed. There's two transformations. Everybody see two separate things. One is we've got a plus 5 in the parentheses with the x. So remembering from earlier in the year and looking at your review notes, you just wrote down what way does it move when something's in with the x. Up and down or left and right. Horizontally, which would be left and right. So we know this is going to have a horizontal translation.
Of 2.
Nope. Of what?
5.
Close.
4.
What's the deal with horizontal?
Oh, the sign is split.
Good. It's always the opposite
-5.
way. So since this is plus 5, normally that means right. We're going to go left 5. So horizontal translation of 5 units left. Horizontal is always the opposite way of the sign. Okay? We good on that part? We've done this earlier in the year. That coming back to you a little bit. Okay, what about this plus 2 that's stuck on the end? What does something just stuck on the end tell us?
It's a
Good. So that's a vertical translation. And up and down, TRANSLAT, up and down got the right
Attention
sign.
teachers and students, please send your Spark Talk Club students to the multi at this time. Thank you.
It does what the sign says. So plus 2 means up, so it does go up 2 units. So there are the two transformations. Okay?
now graph.
Now, when I graph this, I asked you to graph them both, so I'm going to go to this f of x equals x cubed first and graph it. So we're looking here. Now, what do we know about x cubed? The degree is odd. So what does an odd degree tell us our ends do on a graph? Do they go in the same direction or do they go in different directions? Different. Very good. So I know it's going to be a lightning bolt looking graph. Since my leading coefficient's a positive 1, I know it's going to go uphill first. Okay, bless you. So I'm just going to plug a few random numbers in and go with that. I'm going to do -2, -1, 0, 1, and 2. See if that gives me anything to look at. So if I plug in -2 in for the x, what's -2 cubed? -2 times -2 times -2 is -8. If I plug in -1 in, what's -1 cubed? -1. 0 cube's easy. 1 cubed and 2 cubed. Okay, so that ought to get me a good graph for the f of x. I'm going to count on every line. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 1, 1, 0, 0, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8. Ooh! Get off there.
Oh man.
So it should look something like that. Now, my options, that's f of x, right? My options for graphing g of x. I could make another one of these tables and plug stuff in, but the easier thing, what I'm going to do is I'm just going to take each of these points and I'm going to do what the transformation says. I'm going to scoot them all 5 left and 2 up. Okay, so I'll do that one here in blue. Let's go 5 left, 1, 2, 3, 4, 5, 2 up. 5 left, 2 up. 5 left, 2 up. 5 left, 2 up. 5 left,
2 up.
2 up. So there would be g of x. Now Trevor asked about could you graph those in the calculator? Yeah. They're both solved for y. Hit y equals and type in the equation. And you could go to your table and find those points. What we need on that one? I want you to try that one. Describe the transformation from f of x to g of x and then graph them both. Go.
How many numbers do you like in the table most of the time?
4.
Yeah, a line I do 3. Anything bigger than a line I do at least 4.
Yep. That was good. I know that.
Do what?
Trying to cool off. It's hot.
I'm not
Told you.
hot.
Turn that
I'm
air on.
hot. But I'm the one who freezes in 60-degree weather, so. Well, yeah, it's 60 degrees.
About right? Is it right there?
Yesterday at lunch, I was reading.
Do you know what he asked?
It's cold today.
How about that?
Okay.
That's the vertical.
I'd rather it be cold. I mean hot. Because when I'm cold, sugar.
That's all I can do.
I don't really care, so either way, I'm gonna start.
You will. Show me the game. Show me the game.
You know what'd be a good idea for trick-or-treat? I mean trick-or-treating, like handing out candy. Going to get like 100 corn dogs from Sonic, so only like 50 cents today, and just giving them out to kids. 'Cause I mean, when you're walking around, you get hungry.
Ain't nobody gonna take no corn dog though.
Huh?
Ain't nobody gonna take no one's corn dog because look at this poison.
It's
I mean,
the
that's
same thing with
Sonic.
candy.
Yeah.
You can poison candy.
You can poison a corn dog way than you can candy because it's out of a wrapper, and then you put back candy. You have to
You
crack
can
the
make your own
syrup.
candy.
That's still expensive.
You can make your own candy.
And most of the time, parents won't let
Oh
their
yeah,
kids
that's
eat
what
the
it
candy
is.
if it's made.
Mark Gibson's parents will roast some hot dogs
No.
and give them out to kids. And I mean, roast some marshmallows and
No,
They
really.
eat at all, like outside of the box.
Most of the time, you don't go to houses and they give you homemade candy. They'll give you candy in a wrapper. You must be going to the.
Okay, what transformations? What transformations took place?
Horizontal
Right to
translation
the
to the
three.
right.
Okay, so Dalton said right 3, a horizontal translation of 3 units right. What else?
Vertical translation.
Vertical.
Down 1.
Very good. Okay, when I get ready to graph this, what should I expect it to look like? Should the ends go in the same direction or different directions? Same, because it's an even number degree, so they're going in the same direction. Are they going to go up or are they going to go down? Up, because it's a positive x. So this is going to look similar to a parabola. It's not a parabola because it's not squared, but it's going to look similar to that. Probably have a flatter base, doesn't it?
Yeah.
Did y'all get it graphed? All right, so I'll do my same ones I did a minute ago. 2 is going to be pretty big.
Yes.
Yeah, they are big.
2 times 2 is 4 times 2 is 8 times 2 is 16. It'll be a positive. 1, 0, 1, 16. Those right? I plugged those in for the x. So if you did negative 2 times negative 2 times negative 2 times negative 2, negative 1 times negative 1 because it's 4th power. Alright, so I go negative 1, 1, 0, 0, 1, 1, and then the 16s are going to be way up there. Now, if you looked at this on your graphing calculator, did anybody look at it? I could draw that, and it's going to look like it's a parabola if I'm not careful. Your graphing calculator shouldn't look like that. It should be a little bit flatter on the base. Is it?
Yeah.
Okay, so when I connect these, I don't want to make it a normal parabola. I want to kind of make it go more like that. Right?
Right.
Okay, now I need to take each of those points, right 3 and down 1. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. And there will be g of x.
This is easy.
Yeah, it is.
Did we get a worksheet today?
No.
Huh? Is there a test Friday?
Next week.
We didn't have one last week.
I don't know. I wasn't here most of last week.
Yeah.
Where were you?
Yes.
I do have to see. One day I was, excuse me.
Volleyball?
One day I was in volleyball. One day my mom had surgery, and one day there was a mix-up with subs, so I just took a sick day.
And you stayed home at party.
She had a tumor reason.
Yes.
That's what I just said.
We were supposed to miss like 3 days last week.
Yep. But we choked.
Were you here Friday?
Yes, Friday was
Yeah, we had remediation.
Oh, yeah. Yeah, baby, he had his appendix. Did you see the story? Yeah, I know. Yeah, it was in your guys. Oh, my people slid over. Oh my God, wound up. Is that what you said?
Yeah, that's what it was. I remember that. Then the other one was.
Alright, let's talk about the transformation. F of x is x to the 4th. G of x is negative 1/4 x to the 4th. Alright, so from f of x to g of x.
No. It's vertical shrink. Told you, bro. No, it's
Okay. Landon and Dalton are thinking good over here. I'm just, when I do this, they're a little bit ahead of me. I just look at it left to right, and the first thing I see is the negative. So I want to address the negative first. Y'all aren't wrong on what y'all were saying. So what does a negative out in front tell me? A reflection. And I got to figure out if it's going to be a reflection on the x-axis or the y-axis. So looking at your reflection, when it's just stuck out in front with no parentheses, it's the x-axis. So I'm going to reflect this over the x-axis. Okay, now in front of, after that, I've got a 1/4. Okay, looking at the table that you copied down, a 1/4, it's not in the parentheses or anything. See the horizontal one, it's got that in the parentheses, right? So I'm down to the vertical, and it's smaller than 1. So it's a vertical shrink. And does vertical stay what it is, or does it take the reciprocal? It stays what it is. It's horizontal that takes the reciprocal. So that'd be it. That a kid.
That a kid.
Yeah.
That a kid.
But it was older than older.
Good? Alright. Okay, no problem.
Alright, you're good.
What happened? We're not gonna graph it?
No, we already graphed a couple
Oh.
more. We got good practice on graphing.
Well, can you do the graph or the charts for that one? I want to see if I was right.
Oh, I don't even have one down. I can look at yours and tell us.
Why?
Probably Quizlet questions.
No, they weren't today.
This one? Did you have to copy that?
No. The ones should say
Graph that.
2 to the 4th would be 16.
No, you're
1 to the 4th would be 1.
Saying there's
Oh, I
not
thought
one
you
that
just
you
had
from
to
the go back.
You know how to do a 4th power?
Yeah, I did.
But I didn't believe you in that class, but
Oh, I don't know.
know.
Alright, we got f of x. F of x is x cubed plus x squared plus 1. Down up underneath that, we're going to find two different equations. First thing, this is two different problems. First thing we're going to do is we're going to find f of negative x. And then after that, we're going to find 3 f of x. Okay, so on that f of negative x, any guesses on what you think you might do to find f of negative x? It is going to be a reflection, but how can I write this equation? Good. All I'm going to do is everywhere there's an x, I'm going to put a negative x. Okay, so that's going to look like when we start writing that. I'm taking some baby steps from what Stephen said. I'm going to get to where he is. The first thing I did is I just took the x out and wrote the negative x in. Okay, now I'm going to try to catch up with Stephen and I'm going to simplify this. What is a negative cube? Does it stay negative or does it turn positive?
Negative.
Stays negative. A negative times a negative times a negative is a negative, right? So this is going to be negative x cubed. What about a negative squared? Stays positive, so plus, there you go. So this would be our answer for f of negative x, which what y'all said would be a reflection.
So you don't put the negative everywhere, it's just the x. I thought you put it
You put it in front of all the x's, yes.
Right. Okay. Now, other problem I asked you for was to take 3 of that. Okay, so we're going to start that off by saying 3 times x cubed plus x squared plus 1. Now, look at that. What do you think we're going to do to simplify that? Good. Just multiply, distribute that 3 in there. So, good. Now, what kind of transformation was that? We put a 3 out in front of that whole thing like that.
I mean, vertical stretch.
Attention teachers and students, please send all Beta Club members to the new gym. All Beta Club members to the new gym.
It would be
Never been invited to that.
it would be a vertical stretch of 3. Very good, very good.
I looked at that and I was like,
Oh, your little brother and sister and I both went treating them. Nope, they go on Sunday night. They went Sunday. Where's they probably
Alright, there's our function. F of x is x to the 4th minus 2x squared. We got to write a new function that shows a vertical stretch by a factor of 2 and a translation of 3 units up. So we got to take that function they gave us, make it a vertical stretch by a factor of 2, and then scoot it 3 units up. Alright, so vertical stretch by a factor of 2. Look at your notes. Find vertical stretch on there. What does the vertical stretch
You
do?
gotta put a 2 out in front.
It's a 2 out in front, but we got a whole piece here. Landon's right. We got to put a 2 out in front of that whole piece. Now that makes it be just like that problem that we just did with the 3, Landon, right? So we're going to distribute that 2 there. Well, we haven't done that yet. We're going one at a time. Okay? So we're good on the vertical stretch. Okay? Now we're caught up with Stephen. The last transformation we got to do is 3 units up. So vertical translation of 3 up. Carolyn? Just add 3 on the end. There you go.
For some reason I had simplifying the x's.
Well, this one's a 4, this one's 2, so can't do that. If they were same powers, you would. Pretty. Should most of y'all answered questions pretty good. Should have came back to you pretty simple because we did the same stuff with other graphs earlier in the year. Okay, just putting them on these new graphs. Anything that was confusing to you? Very good. When you do any more, call that a day. What's the plan, Stan?
Call it a day.
Calling today. I think we're good on that. That was pretty simple. That's honestly one of the easier things we've done.
Remember at the beginning of the year when we did that, how confusing it was? I got smarter, Dalton.
Yeah.